All right, so we're going to talk about CosmosDB today. All right, first thing, a little bit of housekeeping here. Please silence your cell phones unless you want me to answer it for you, which I will gladly do. All right, just interrupts people, interrupts me. I appreciate that. Now, there's a lot of things that PASS offers, not just Summit. Right? You have virtual chapters where if you have an hour for lunch, you can go and learn something. It's really great, and they're free. Who here is a part of their local user group? Every hand should go up in here. They are awesome. Figure out who your local user group is. PASS, you go out on the site, you actually can find them. Join it, it's really good. That is a local community of like-minded SQL people. And SQL Saturdays. Some people call them little mini summits, but SQL Saturdays are a great way of getting awesome free training. All right, so if you've been to them, continue going. If you haven't, find the one that's in your local block and go to it. They're great places to learn. And 24 hours of PASS. I think we just had that last month. And that's another good opportunity to learn. So the big thing about PASS, if you've seen the tagline, connecting, sharing, and learning, that's what this is all about. You heard this morning, PASS is the largest volunteer organization. We're not getting paid to do this. We're here to help you learn and connect with you. So it's all about that. All right, so who am I? My name is Jim Dorame. I'm a director of data reporting for a large-scale assessment firm up in the Minneapolis, Minnesota area. We deal with a lot of educational assessment data. I've been working with SQL Server since 1995, and really, truth be told, a little bit before that, but I don't like saying it. And the next point on there is extremely valid, especially today. Each new version of SQL Server provides another learning opportunity. 2019 went GA on Monday. SQL Big Data Cluster. Who wants to learn that? I mean, that's awesome. You've got all these new pieces out there that Microsoft has said, we're being asked for these. Microsoft just keeps putting other opportunities out there for you to learn. CosmosDB is one of these. And that's what we're going to go with over today. All right, so our goals are, what is CosmosDB? I'm going to tell you what it is, and I'm going to give you a little bit of history on it. I'm going to show you how to do local development. You do not need to be in the cloud. You do not need to have an Azure account to develop with CosmosDB. I'll show you how to do that. I'll show you how to do the global deployment. It's pretty easy. Microsoft has made it simple for us. I'm going to show you how to import data. I'm going to show you a tool that Microsoft has given us to use that. And I'll show you the querying. Jess Borland, this morning's session, actually made reference to SQL, Structured Query Language. That's a way of getting data out of CosmosDB. It's not T-SQL, but it's a structured query language, so it's SQL-ish. It's something that it's normal. You now can write SQL queries against Spark. Right? So SQL is going to be a language that you always use for everything. Then I'm going to show you how to use PowerBI. It seems like every session at Summit has a PowerBI in it, right? Well, we're going to have a PowerBI here too. I'm going to show you how to connect to CosmosDB locally, and then I'm going to show you how to do it globally too. And we'll make a nice visualization. So what is CosmosDB? CosmosDB is Microsoft's globally distributed, at scale database. And if I didn't say it, please, if you have questions, just raise your hand. I want this interactive with us. So it started back in 2010 with a little project called Project Florence. Microsoft needed a solution to address their pain points that they were having with their large-scale applications. And remember back in 2010, Microsoft wasn't the only one facing this challenge. Everybody was having this challenge. Well, then in 2015, Azure Document DB, who worked with that, or who remembers that? Okay.
Didn't work with it, just remember it.
Well, one of the things is that it was there. It didn't work as good as it could have, but it was Microsoft's commitment to a NoSQL solution. Before that, they didn't have one. All right, so that was in 2015. That's what they said. I'm going to do Azure Document DB. And this was their JSON document store. If you remember, before that, they really didn't have one. All right, it was schemaless and flexible. That's what they were looking for, and that's what they needed. And of course, 2017, Azure Cosmos DB. Who was here back in 2017 when Rima rolled that out and did the presentation? Wasn't that awesome?
I didn't see the presentation.
Okay, it rolled out in 2017, and it supports JSON, but it also supports Mongo and Cassandra and much, much more. And I'll show you those as we go through some additional slides down the road here. Cosmos DB is Microsoft's next big leap in globally distributed at-scale databases. They're committed to this. And you saw that in the keynote this morning. All right, so what is it? It's global distribution out of the box. You put your data where your customers are. It reduces latency. The global distribution is done with a multi-homing API. You no longer have to worry about this. Your application just knows where to go and get the data. Along with that, if you need more, just add additional read regions. So let's say you have your customer base starts out in the Midwest in the United States. And then you add on a customer over in London. All you need to do is add that additional read region in London. Your data is replicated over there. And now, because of the multi-homing API, you don't need to redeploy your application. Your London clients know, oh, I go to my London data center. And you can add in additional data centers as you need them. Yes?
Is it kind of like a replica within, similar to what MongoDB does?
So is it like a replica of MongoDB?
Yeah, in a sense, like, okay, within what they kind of like have a clusters, they have replicas where data is stored on all of them, and eventually they can sync together at any point in time. Something like that?
So the question is it kind of like MongoDB replicas where you have multiple servers or clusters of MongoDB, and it eventually gets written all over the places? Well, sort of, right? Because as you'll see here, Azure Cosmos DB has 5 consistency levels that you can work with. Yes, so we'll get into that as we go into some more slides here. But the point I'm getting across here is you don't have to worry. You get to decide where your read regions are. And you can roll those out yourself. And again, like I said, your application doesn't need to be redeployed. It just says, oh, I know where I'm going. Now, along with that multiple or global distribution, you have multiple data models. Remember I told you had JSON? Well, it all starts with ARS. The atom record sequence. That is what Cosmos DB is built on. And with that, you can have a document store, or JSON. You can have a graph database. Cosmos DB supports a graph database. You have a key value pair. You can do a table API or a column family. This is all because of ARS. All right, so think about that. You don't have to pick one or the other. You can, oh, okay, I'm going to go CosmosDB, and I need a Cassandra container, or I need a Mongo container. All right, so it's extremely powerful. All right, you have popular APIs for actually accessing that data, too. So you're going to have the SQL API. Again, structured query language. It is not T-SQL. You have to understand that. It is SQL-ish, is like I have to say it. You have a MongoDB API. If you have a Mongo application already on-prem, all you need to do is transfer your data into the cloud in a CosmosDB, change your connection string, and you are now in MongoDB. You don't have to change your application. It supports the MongoDB API. You also have Cassandra's API. You can do the same thing with Cassandra. Gremlin, who's working with graph databases right now? I know that's the next big thing you want to work with. I haven't played with that yet, but it'll be interesting to work. CosmosDB supports that out of the box. You know, the standard table API is available too. And there are additional data models and APIs coming. Microsoft is working and adding new things to Azure all the time. So I wouldn't be surprised to see additional data models coming down the road. Now, you get to scale. You do. Not Microsoft. You scale it. Throughput and storage on demand and globally. All right? You need more or less. Just scale it up or down at a per second granularity. If your requirements change, again, no problem. You control that. You add whatever you need or whatever your credit card will support. But Microsoft doesn't do anything for you on that. Now this is, you build highly responsive mission-critical applications on top of this service. It is fast. You look at that, it's 99th percentile end-to-end low latency. Just look at that, 1K document. An end-to-end latency is 10 milliseconds on a read. You think about that. How fast that is in the cloud. Now, it's not only fast, but it's always going to be there. You have always-on availability. 99.99 SLAs for a single read region. You go to 5 nines on a multi-region database accounts. So it's fast. It's always available. Right? And again, like I said, you need more. You get to add it. So it's fast, it's always available. And here, you write it the right way with 5 well-defined consistency models. This is where I was getting into the fact that there are 5 of them. And yeah, it's kind of crazy. There's 5. You go from strong SQL-like consistency all the way to the NoSQL. Yeah, eventually it'll get there. All right, Microsoft's site, if I remember, I can't remember the right page I was reading on, but the default for CosmosDB is session consistency, right in the middle. Microsoft stated that 75 to 80% of all workloads of CosmosDB are within that. They fall within the session level. It's fast, it's always available, and you have money-back guarantees. Microsoft is putting their money where their mouth is on this stuff. They have industry-leading, financially backed SLAs for availability, for throughput, consistency, and latency. If you configure it and you're paying for this and it goes down, Microsoft gives you your money back. I don't know of any other cloud provider that has that. And all of this comes at a low cost of ownership. It is 5 times cheaper, cost effective, than an on-prem NoSQL solution. It's 3 times cheaper than AWS, DynamoDB, or global, Google Spanner. Now, all of this is because there's no database schema or index management. You get to build this, and you don't have to worry about what schema am I going to use. Do I need a data architect to define my schema and work with it? And am I locked into the schema for my application? No. It will rapidly iterate your schema of your application and just work with it. You need to add additional members to your JSON or your schema that you're working with, just add them in. You don't have to worry about your old data not working with your new data. I mean, that's the beauty of this. Excuse me. The database engine it's schema agnostic. And it just ingests all of your data and indexes it at ingestion. Now, speaking of indexes, CosmosDB has 3 index types. You have a range index, which are going to be used for your, a spatial index. And then you have the composite index. All 3 of these have very different use cases and are required for you to understand and work with them. So the range index, that's used for equality queries. It's used for ranged queries, single order by queries, and joins. And this isn't, when I say joins, when you're working with documents, it's not standard table joins that you're working with. You're actually joining within that document that you're working with itself. So if you have multiple pieces within the document that you're working with, that's how you can do a join within that. It goes beyond this class here, but that's one thing you have to understand is when you're working with a document, it's not a standard join. All right, that's your range index. Then you have your spatial indexes for dealing with all of your graphing, and that's where your geospatial distance queries come in. Also, your within queries. Now, there are some limitations to this, because currently supported, you only have point and line strings, polygons and multi-polygons. But as this grows, you'll have more capabilities. Now, the last index is kind of interesting. It's the composite index. And this one is very important, and when we get into the demos, I'll show you why. The big one here, if you need to do an order by on multiple properties, you need a composite index. If you need to do a filter and an order by, you need a composite index. If you have to have a filter with 2 or more properties, where one is an equality filter, you need a composite index. So as you see here, it's very important to understand what your application is going to be doing so that you can get the correct index strategy. All right, so that's what CosmosDB is. Are there any questions on that? Does that make sense?
So with the indexes, you mentioned it sounds like it's all automatic. So is it choosing what index to create on the samples that you create, whether it's composite, spatial, whatever?
So the question is when you ingest the data, what index is it suggesting, correct? Or what is it using?
Like, am I setting this to use the composite indexes based off what I know how it's going to be used, or is it doing it under the hood?
Great. So the question is, do I set what the composite indexes are, or is it doing it under the hood? So the pieces to that is that on ingestion, every property is indexed. And that's done through a range. Remember, because the range index uses single order by, joins, standard filters. So when it ingests, it creates ranged index on every property that you have in there. If your application requires a composite index, you need to determine what that is, and then you have to build that. And I'll show you how to, in one of the samples, I'll show you how to add a composite index. Great question, thank you. All right, so this is all about working locally here. I know Microsoft wants us all in the Azure cloud, and it's a great place to be. But we're going to work local and deploy global. So the step one, Microsoft has provided an emulator for us. It's the Azure Cosmos DB emulator. Requirements are pretty standard. Windows 10 you can run it on, 64-bit operating system. You need 2 gig of memory and a 10 gig available hard drive space. That's all you need to run the emulator here. Now, there are differences between the emulator and the service, obviously. Right, again, just like it says here, you're on a local developer laptop or a local server. All right, so our differences are, when you get into it, the Data Explorer only supports the SQL API and the MongoDB API. That's the Data Explorer. You can still create those other collections and use that other data, but you can't use the Data Explorer that ships with the emulator to view those. You have to write your own. All right, it also supports a single key. You cannot regenerate, because everything is key-based. It's not a scalable service. It's on your laptop, and you're limited to the number of collections that you have. By default, you have 25 fixed size containers that you can use, or 5 unlimited. Now, with modifications to your partitioning count values, you can increase that to 250 fixed or 50 unlimited, or any combination therein. You do need to be careful, though. This is not a scalable service, right? So I believe in Books Online it specifies that you want to stick around 200. You don't really want to go over 200, because you actually then could get a service unavailable call, right, if you're working there. So it's not something you want to try to put in a whole workload process on the machines. It also doesn't allow you to use the different consistency models. Right, you're limited to the default session. And it doesn't support multi-region replication, obviously. Here's a big one. You can use the emulator to kind of work through what your RUs are going to be, right? But it doesn't support the service quota overrides. And like I said, you can work through what your RUs might be. Who here knows what an RU is? Awesome, I'll get to tell you this. So RU is the currency of throughput. That's why I have that on their website. It's really cool. I'm like, oh, I get to use that. Basically what it is they take their compute, their storage, and their memory, and they put it together, and they say, all right, regardless of what platform, or not platform, what data model they're using, This is the resource unit cost for this. And it will, if you're on Mongo or if you're on SQL API or on Graph, an RU is an RU. You don't have to worry about that different levels. They've worked out what the costs are. Now, there are specific considerations that you have to have when you're dealing with RUs. Number one is your item size. That can increase the number of RUs that you require. What is the size of your item that you're working with? Your item index, that will impact your RUs. Your item property count will impact it. Your index properties, how you are indexing. And then finally, your data consistency, how you want your data consistent will impact your RUs. So these are the things you have to work through to figure out, all right, how do I want to do this? What is it going to cost me? And this emulator will help you with that, which is why I think it's a huge plus. All right, the local emulator, let me show you what it is. It's really simple. Once you've downloaded it, you'll have an option on your Windows bar that says Azure Cosmos DB emulator. You click that, it runs the service, and it loads up this web page. And this is what the emulator looks like. Now, you can do this all through PowerShell if you want. There's a PowerShell module that you can run the emulator and bring it up through PowerShell. Also, if you want, you don't have to install the emulator on your machine. There's a Docker container out there that has the emulator in it. So if you want to run Docker and run the Cosmos DB emulator, you can do that. So what you have is you have the quick start here, and this primary key, again, this cannot be regenerated. That's the key that it showed up with, and I can't regenerate that. You notice that there's only two connection strings. You have Mongo and you have the primary. Remember, that's because the Data Explorer only works with SQL and Mongo. And speaking of the Data Explorer, this is what the Data Explorer looks like. We don't have any databases in here right now, but that'll be the next step. But this is the emulator. This looks exactly like what you would see in the cloud when you're dealing with Cosmos DB. Yes?
If you're using the emulator, say you have flat files in blob storage in Azure. Can you access those in the emulator? Or would you have to then do everything on in the cloud?
So the question was, if I have flat files in Azure blob storage, and I wanted to consume them into my emulator to work with it. That's a great question, and it'll be answered in the next series of slides here.
I don't want to pull them down and then put them in and do that over and over.
So we'll go through the next series of slides. If it answers your question, great. If not, we can talk later on that. So that's the local emulator. It's pretty simple. You bring it down, install it, and that's what it looks like, and you can work with it. Yes?
Sorry, you might have covered it. Is the primary key that one you said about only one master key? The limitations for the local Cosmos database, you said there's only one master key.
So the question was, is that one of the limitations of Cosmos DB local emulator? Is that I only have a single master key not regenerated? And yes, with the emulator, you only get a single master key and it's not regenerated. It gives you that key and that's it. Right? It's an emulator. It's not meant for production processes. All right, so that's the local emulator. So that's step one for us to start working locally. And it didn't cost us anything other than some bandwidth time to download it. All right, so step two is you need to actually load your data. And this is kind of what I was saying here is, to your question, there are a couple of different ways that you can load the data. So Microsoft has given us another free tool. That free tool is called Azure Cosmos DB Migration Tool. And here's the link for that. Or, as you heard this morning, and actually I saw something, some slide someplace, Azure Data Factory. Azure Data Factory has over 80 plus connectors to working with data. And here's the link for that. Or if you want to, you can write your own. There's a fully documented API to work with Cosmos DB on importing data and how to work it, how to bring it in. And if you noticed on the emulator page, there was examples for .NET, .NET Core, Python, Node.js, I believe. Right, so it is a well-documented API of how to put data in, how to put data out, and work with it. So one of the things, I go to a lot of conferences and I go to a lot of sessions, and one of the things that frustrates me is I'll go home and I'll start working through the sessions, and the presenter had done some demos. And I can't figure out, well, how did he do that or how did he do that? So what I have here is I have every step-by-step of the process for importing your data. So when you go home and you download this, you can follow it along and go back and say, oh, this is what I need to click here. It's just something that I want to do in my presentations because it seems to be I've been frustrated with it because how did he do that? Well, now you can actually see it.
Where is that available?
Pardon? So where is this available? So PASS has these available for download on their session pages. I don't have the link here right now. But you can download the presentations. They're in PDF format. All right, so we're going to use the Azure Cosmos DB migration tool. And this is what it looks like when it starts up. It's very simple. You have a source information and you have target information. And there are some advanced tabs. I'll show you through those. And you just click the button through there. It's pretty nice to use, and you can save it off and run it through a script if you want to. We're not going to do that for this session here. But first thing you need to do is you need to select a source. Now, these sources can come from a JSON file or files. They can be CSVs, and you just point to it wherever it is. It can be a SQL database. Now, the one caveat I have to say on the SQL database is if you have JSON stored in your SQL database, say in an nvarchar, don't expect just to use that column and tell it to put it in here. You have to work through a couple of different methods to actually take JSON that you would have in your database and bring it into Cosmos DB. That's beyond this session, but if you want to talk about that after the session, I can show you where to get that information. You can go directly from MongoDB. If you want to go from a MongoDB export, you can do that. You can go from DynamoDB. You can pull information out of an Azure Cosmos DB. Right, so all of this is where you can pull your information from. Those are your sources. Today, we're actually going to use CSVs. I don't know if that answered your question or not. Okay, great. Once you have your source, like we have here, then you need to move on to your target. And there's two key elements that you need for defining your target. You have to give it a connection string, and you have to give it a collection name. On the next page here, I filled in some information. I don't know if can you in the back see that okay, or let me zoom in a little bit for you on this. So one thing to remember is when you put your connection string in, you have to provide a database name. So it says here, database equals volcano. You need to provide that, whatever your database name is, unless you've pre-created. I mean, this tool will pre-create or create the databases on the fly. If you've already created databases, you still need to name what database it needs to go into. And then you need to give it a collection name. Right? So you have a database and you have collections.
Sorry, I have a question. So on your connection string, I'm not very good at this stuff, so if I ask questions,
No problem.
so that's the connection string you got, and then you bring the semicolon database name.
Yeah, so the question was the,
But that doesn't come with your connection string.
right, the question was, does the database equal come with the connection string? And it doesn't, and I will show you that when we use the tool. The other thing you want to look at also is when you're dealing with this, be in direct TCP mode. There's a gateway mode that can cause you problems. So be in direct TCP mode. And then once you have all this information filled out, you can hit the verify. And it'll go out and make sure you have a connection. Now the other point I want to bring up here too is, you notice this little, it says number of parallel requests, 10. That's the default for this emulator to run against. So it's going to have 10 parallel requests going. For this demo, I'm going to pare that down to 5 because I don't want to overrun my system and get errors. So that's how you can throttle how fast you want to run this information. All right, so once you've selected all of that, if you have errors that you want to run through, and where it comes important here is that say you're going to load 100 files, right? Because you can load up 100 files and have it process all of them. You can have it go to a text file or a log file and log those errors for you. We're not going to do any of that today. And once you've got all of it selected, it's going to say, all right, are you certain this is what you want? So you look at your source, you look at your target, and then you say, all right, I'm good to go, and you push the button. And that's what we're going to do right now. And there is no way to increase the font on this tool. This is it. So I will zoom it so you actually can see the information, and then I have to bring it back down so I can work with it. But this is what it starts out with. You start your migration tool on the 2 big red exclamation points. Those are the ones you have to fill in. So I'm going to go ahead and pick our source information. And I'm going to use CSV files. I've downloaded this. This is free data off of the internet. It's from the NOAA website. It's volcanic research. So I'm going to pull this information here. So I'm going to add these file. I'm going to add a file in. I'm going to bring in volcanoes. And I'm going to say next. And this is where I need my connection string. So I'm going to go over to my emulator. And this is my connection string right here. So I'm going to copy this. Come on. And I'll come back and I'll paste this in here. Now, like you said, that's all you get. You have your connection string. I now have to add the database equals volcano. So you need to tell it what database that connection string is going to go to. I'm then going to have it, yes?
You said you don't have to pre-create that database. This tool will help you to create it in Cosmos Emulator.
So the question was, you don't have to pre-create the database. And no, you don't. So you notice, if you look at my emulator here, I'm going to go back to my emulator and look at my Explorer. I have no databases here, do I? It's a completely empty emulator. You can, however, and you'll see that, import into an existing database. All right, so I'm going to actually put this in a collection called Volcano. I'm going to bring my number of parallels down to 5. I'm in direct TCP mode. And let's go ahead and verify that I actually have my emulator running and I can do my connection. And it goes out, does the test, and hopefully it comes back. Come on. It worked well in practice. There we go. We're live. So now all you need to do is you move on to the next screen, which if you wanted to create an error log, this is where you would do that. And then next, and I'm just going to run this. Here's all the information, my CSVs, my location of where I'm going to put the information. Zoom in here so you can see that. My connection string, the collection. I'm running a throughput of 1,000 RUs. That's what, remember, the RU is your currency. That's your throughput currency. So this one is defaulted to 1,000. And then all I need to do is run import. Now it's going to go out and it's going to read that CSV file. And it's loading up. You'll notice here it's changing 814, 924, 1,036, right? So it's loading that information into my local emulator. And this would be where you would have to point to your information in the cloud, and it does load it here. You can't attach to that. It has to ingest it. Remember, because you're bringing it into a CosmosDB database.
So say there's one flat file. You're bringing it from the cloud into the data. Where is it living once it's in Cosmos?
Okay, so the question is, where's this living when it's in Cosmos? So with the emulator, it's on your local hard drive here. So there's underneath it, it's a data stored in your local emulator. In the cloud, they have a file system where they put this information in. Does that help?
Yeah, I'm just trying to imagine where the data are, like file, but that's the site.
That's some underlying architecture of CosmosDB that goes beyond this. And I'm working through some of those pieces to understand a little bit more of the deeper architecture. I'm certain that there's some Microsoft engineer here that could answer that question for you.
I don't think I need to know.
Okay.
Just curious.
Okay. No, that's a great question, though. Yes?
Can we still use any of the APIs to access once it's imported, or are we stuck with because we imported using the standard endpoint? We can only use one API to access it.
So you can, okay, so the question is, can I use multiple APIs to access the data? I'm creating a SQL API. That's the only API I can use. You define what your API that you're going to be utilizing. So if you want Cassandra, you define it as Cassandra. If you want it as Mongo, you define it as Mongo. You can't cross that information. A container can't contain more than one structure yet. That may be coming. I'm not officially saying anything. All right, so we've imported our volcano data. Well, I've got another file I want in there. I've got eruption data. And I'm going to go and I'm going to say new import. And I don't want to reset everything, but I'm just going to come back here. I'm going to delete this file. I'm going to add another CSV file, the eruptions. Now, I could have put this all into one container and worked with that, but I wanted to show you that, number one, I'm going to put this into the volcano database. I'm going to have more than one collection. I'm a volcano, I'm going to have an eruption. And I'm also going to show you, I wanted to show you how to work with two collections at the same time. So you don't have to have just one collection. I'm going to change my collection from volcano to be eruptions. Leave my parallel the same as 5, and I'm going to go ahead and import this. Again, no errors, and just import it. Now again, it's going to go out there, it's going to take that CSV, and it's going to import it. It would do this with JSON files. It would do this with any of the other imports that you would wanted. All right, so it's going to run through here in a few seconds here. It'll be finished up. And we're done. We've now imported our 2 data sets that we want to work with. Let's go over here and let's hit refresh. As you see there, I had no databases, and the emulator, or the import tool, actually created the database for me before it loaded the data. And here is, I'm going to go to open up this volcano and look at my items. And this is what's stored in my JSON, or in my CosmosDB database. Here are my members. And you'll notice there are, you see underscore row ID, underscore self. That was all added by CosmosDB so it could use those fields within its own development, right? You would access that through the APIs. Now that works fine there. I'm going to show you, I have some pre-built queries. So I'm going to open some queries from disk. I've just got a standard select here. So rather than doing a select star, I'm going to only select these 5 elements. Now, the one thing here that I want you to notice, this little syntax here is, I strongly believe, it's Microsoft's way of punishing you for having a space in your names. Because you have to have the C, which is your collection reference, no dot reference to it, an open square bracket, and quotes, all to get a column that has a space in it. So my point to you is don't put spaces in your names. But I'm going to go ahead and run this. I imported the data, and it's now in my collection here. This little query stats is extremely important. This shows you what your request charge is. You'll notice that little select statement was 11.79 RUs. And it maps pretty good to in the cloud. That little select statement will be 11.79 RUs. That's what it's going to cost you. It also gives you the other information too of, all right, how many results are being shown? I'm going to do a 1 of 100 there. What is your retrieved document size? So it gives you all of this information so as you're building your application, you get instantaneous feedback at no cost. I mean, think about that. This isn't costing you anything. I have another query here. I'm going to go ahead and open up one. Actually, I'll just add this one in here. I'm tempting the demo gods, Buck. I know that. I want to say, not aware. I want to order it by country. I'm going to go ahead and run that. See? Thank you, Buck. So I did an order by. And I did a straight order by, and that information worked out fine. My query stats, look at what happened to my RUs. 16.189 now, because I added an order by. So one of the things you want to think about is do I need to do this in my CosmosDB database, or can I bring the data down and have my application do it? So you have to start thinking a little bit different of how you want to do your data manipulation or data processing. So that order by worked fine, didn't it? Let's open up another query here that I've got pre-built. I want to actually do a query that says order by type and country. Think I'm going to be okay to run this? Let's find out. I got an error. I want to say more details. And the errors are pretty good. It says, you asked for an order by that doesn't have a supporting composite index. Remember I told you, if you have more than 2 properties in your order by, you need a composite index. So I ingested the data. It added the indexes that it, for every column or every property that was there. But because I said, oh, I want something special, it had no clue how to do it. And so now it says, hey, you can't do that. But that's fine. We can control that ourselves. I just so happen to have this is how you add a composite index. It's JSON. Everything is JSON. So you just specify the path, an ascending or descending, of your fields that you want. So I'm going to go ahead and grab this. And the special place you put that is over here in Scale and Settings, under your index policies. So I'm going to replace, so you see here we have ranged, your indexes are ranged, and range for your string. That's all you have. I'm going to go ahead and replace all of that. You notice here is change the TTL or indexing policy impacts query results with the index transformation occurs. Fine, warning. I'm going to go ahead and save it. I've now added a composite index. It's that fast. I'm done. I'll go back to my query here. I'm going to run it. Boom. It now works. What did that do to my query stats? Well, it went up a little bit. I'm at 16.239 RUs now. But you're like, well, Jim, that's great. But I want to order it by country and type. I'm like, okay, great. I got a query for that too. Let's go ahead and open that one up. I'm going to go country by and type here. All right, so I've got country type. Who thinks this is going to run okay? All right, you've been here. All right, I'm going to go ahead and run this. Even though you have, well, let's see what the error says. Guess what? The order by query does not have a corresponding composite index. Even though you have a composite index that contains the columns that you want, because they are in a different order, it doesn't know this. So you have to add another composite index. And I just so happen to have that one pre-built too. And this is how you do that. You just add it in there. The point I want to get across here is for a composite index, if you have your column order is different, you need a composite index. If you have your sort order different, say if you have your type is descending and your country is ascending, you need a new composite index. So think about that as you're starting to build these things. Do you really need to have these? Because remember, this is impacting your RUs. Each one of these will increase your cost. I'm going to go ahead and add this, replace my index policy, come back over to Scales and Settings, close my window down. And now query 3 works. So one of the things is, it's an important thing to remember, that composite index is how you want to do it. Now let's see if that impacted my query stats here. What was my RU costs? Huh? About the same. So that's querying data, working with data once you've imported it and ingested it into CosmosDB locally. Now, it's beyond the scope of this class, but you can create stored procedures in CosmosDB. You can create triggers and functions. Now, y'all need to learn JavaScript because that's how you do it. Yes, sir?
What is the overhead for creating a composite index? Are you creating some sort of structured tree, like a non-clustered index, on an unstructured data? How does that work?
So the question was, what is the overhead for a composite index? Is it becoming a structured tree? That's a great question. Actually, I'm working on a presentation on indexing in CosmosDB because it is so different. Just as a point, when it indexes, what it's doing, remember you have a JSON document. What it's doing is it's following the path.
That's why you can't flip them.
Exactly. Exactly. So when it follows the path, it says, oh, I need this piece and this piece here, and it creates that own pathway there. So it's a little, that's why I say it's a little bit different. It's not your standard B-tree. So there is, I mean, that's a great question, which is why I'm actually working on that presentation. Because you do have to think about indexing different within CosmosDB. So thank you. Any other questions on that? So the question is does index only matter when you're dealing with the ordering, or can you do filtrations? Does it impact and help your filtrations? Well, it does. You can remember one of the, I believe it's on the ranged index. That's where your filters, a standard filter, will come in and actually can help you with that index because it goes directly to that and filters the information out for you. So you could decrease your RUs by using that. But again, this is where you can play with it and not cost anything. You want to try an index out? Add it. Right? Okay, but one of the things I want to go back there too is that you do need to learn JavaScript because JavaScript is how you write stored procedures, functions, and triggers, which you can all write in CosmosDB. But you have to do it in JavaScript. Yeah, I wasn't real happy when I figured that out either. Yes?
I'm assuming there's a design reason for that?
Because you're in the cloud. But no, there isn't. Everything is. I don't know how to say it. Other than, I mean, you're in the cloud. I mean, that is JavaScript is cloud native language, that you're working with, and it's running on. I mean, a lot of. I was talking to a developer friend. He said, "So they're running on Node.js." I'm like, I don't know. But yeah, you have to translate. It has to work through that. All right, so that's working with the data emulator. So you've imported it. And this is the deploy global piece I want to show you here, right? So this slide here, I've created a CosmosDB in Azure Cosmos in the cloud. This one was going to be a core SQL. It was going to be in Australia East. I was going to have any geo-redundancy or any multi-region writes. It's just a standard. So this is how you would create it in the interface. Or as Jess said in her presentation this morning, you can create this once, download the resource manager template, and then you could script this, and it'll take you 10 minutes the first time and 2 seconds the next time you need it, because you can script it out and just run it through PowerShell. Now remember I told you you have the control over scaling. Well, if you look at each one of those hexagons, that's a region that you can put your data in. Remember I told you if you had new customers over in London, Well, there, it looks like there's 5 regions over in the UK. And you can pick those there. Now, depending upon the size of your data and your consistency model, it can take some time to replicate it over. Right? It's not going to be instantaneous. But if you need that, you just click the button and you control it. You don't have to ask anybody's other than your finance company or your finance department for rights to put that over there. So that's how simple it is just to deploy this globally. A few click of the buttons and you're off and running. And this is the Data Explorer in the service. It looks the same, doesn't it? All right, this one here, I've set my throughput, again, my RUs, my throughput currency, to 500. You can go all the way up to 1 million if you want, or your credit card affords it. And this is where you can define that. All right, so I've showed you the emulator. I'm running it here. I've showed you the tools to bring it in. And all of this is free. We've not spent any money whatsoever. I'm going to show you another free tool to make it look good. So I'm going to use PowerBI Desktop, which is a free download from Microsoft. It's actually one of the really good visualization tools that's out there. You're going to connect to the local Cosmos DB. We're going to go up through some mashup data. I am not a Power BI expert here. I can fumble through it. So don't ask me too in-depth Power BI desktop questions. And then we're going to create a visualization. And it's all working with Cosmos DB local data, which then once we're done developing that, 2 clicks of the mouse, and I'm in the cloud. And I'll show you how to do that. So the first thing you need to do is get your data. So Microsoft has got a connector to Azure Cosmos DB. It says it's a beta. It's been beta for 2 years. Don't worry about it. It works. All right, once you've got your connector, it says, all right, where do I go to look for this? And you put in your URL of your local emulator. You can define your database if you want to it there and your collection, but you don't have to. Once it's connected, you'll see, oh, I have my database and here's my collections. And one thing you'll notice here, it just says record, 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 record. What are we looking at in this Cosmos DB collection? JSON. Power BI Desktop doesn't know that yet. It just says, oh, I've got records. There's another step you have to do, which once you've connected and imported, you actually have to go into the query editor and expand that record so you actually can work with the columns that you want to bring in. So once we've done that for both sets, we're actually going to use a feature in Power BI Desktop that allows us to merge 2 queries together and create another query. And I wanted to do this to show you that I've got 2 separate collections in my Cosmos DB. I'm going to bring them together as one data set that I'm going to use for my visualization. Now, if you wanted to, you could have gone through and worked that out in your Cosmos DB ingestion process. But I wanted to show you that you can work with 2 separate collections. And then we're going to put it on a nice visualization. We're going to put it on a map because we have latitude and longitude information. And let's go ahead and build that right now. So this is your Power BI canvas. Fires up, this is what it is. It's all blank. First thing we need to do is get our data. And we'll come down to Azure. an Azure Cosmos DB, and we'll connect. You get the, hey, this is a preview. Okay, yes, I understand. I won't come yell at you. I'm going to go over to my emulator. I'm going to go up to my quick start. I'm going to grab this URI right here. That's all I need. Come back in here, plop it down. Now again, like I said, you could put in your database in your collection in here if you wanted to. I'm not going to, because I'm going to have it selected the other way. It's now connecting to my local Cosmos DB. You see here's my volcano and my 2 collections and our records. So I'm going to load those. Now PowerBI desktop, you can do a live connection or you can do a load. There is no live connection to Azure Cosmos DB. Right? So you're not going to get, like they showed this morning, the streaming analytics. You need to actually use the PowerBI service to work with that. So just wanted to give you a caveat or the warning there. Now here's one frustrating thing. I've clicked OK, and I've come back to the blank canvas. You actually have to go to Edit Queries. It will not bring that up automatically for you. Now you see here, we've got our document and records. I'm going to hit my little expansion here on my volcano, and it expands out. And those, as you'll see, all the columns that we had in our selection in the data emulator are there. So I'm going to not pick all of them, but I'm going to bring in volcano name, country, region, latitude, and longitude, because I want to put it to a map. My elevation is going to be an aggregate that we're going to work with. I want type and status. And that's all I want to bring in. I'm going to go ahead and say OK. And my elevation, I want to move that, change the data type to a whole number. Okay. Get rid of that. Okay. And then we're going to do the same thing over here for our eruptions. We don't want all the fields again. I want a year. I need the name because I'm going to link on that. But over here, I'm going to also bring in, this has got my aggregates, right? I want to bring in total deaths, total missing, total injuries, total damage in millions, and total houses destroyed. And those totals I want to have as numbers, so I'm going to go ahead and change those data types also. Now you notice here, on the side here, applied steps. It's keeping track of everything that I've done to these data sets. Right? So I've got a source, I've got a navigation, I've got an expand document, I've got change data type. That's very important to remember. And I'll show you that when we go to the cloud. Now I want to actually go up to this merge queries area. I want to combine these queries together for, I have one data set to work with. So I'll say merge queries as new. I'm sitting on eruptions. Actually, I want to change this to volcano. Come down here, choose eruptions. I'm going to go by name. And that's going to be my link. I'm going to go ahead and say OK. And it's built out a new query. I'll give it a name. But you also notice when it imported, it just said table. You have to expand that also so that you can utilize it. All right, so I've now mashed up all my data. I'm going to go ahead and say apply. And it's working through that information and building out my data set. I want to hide these two because I only want to work with the data that I've got. I'm going to throw a map on here now. And with the map, you have longitude and latitude, so I'll grab that. Longitude. Come on. The size we said we're going to use as the aggregate, so we're going to bring in our elevation. And then for our legend, we're actually going to use country. So let's build this map very easily with just the CosmosDB data that you have right now. I want to put in some slicers so I actually can get slice down and interact with this map. So I'm going to add one here. I'm going to add region. I'm going to add another one. I'm going to say add status. And then I'm going to add another one in here that I wanted to bring in, say, total number of $1 million damage in millions. You'll notice that PowerBI actually chooses a slider bar or a checkbox selection for you. Well, let's go ahead and see how interacting with this. So I'm going to choose Africa, East Africa. Well, I just got back from a trip to Kenya, and I should have actually looked at this demo before I went there, because I didn't realize there was all that activity, volcanic activity in Kenya. But luckily, they're not active. So it's kind of interesting that this is all interactive right now. So that's bringing it out of CosmosDB and showing it up, mashing it up in PowerBI. Now that's your visualizations. Yes? The question is, can you connect to CosmosDB from Azure Data Studio? I don't believe so. Sorry. So that's the visualizations. Now, to go online, right, because you have spent months working with your application, not costing your company any money because you've done it the local emulator. You've used all of the tools locally, so there's no cost to your company at all, but now you're ready to go online. Well, if you want to do this with PowerBI, all you need to do is edit your queries. And remember this little applied steps? This button right here, that little star or gear or whatever you want to say, I'm going to go ahead and click on that. Okay, click on that. And it's going to come up and say, where do you want to connect to? So I will go out, and I'm going to grab my read-only keys for my live CosmosDB in Azure. I'm going to paste this in here. I'll do the same thing for this source. And that's it. Now I come up here and I say close and apply. It's now going out to the cloud. Bringing that data in, I've pre-built everything, and I'm now done. I've now deployed globally. I'm off and running in the cloud, working with this. I can send this to anybody if they're in the UK. If I've got a read region in the UK, they've got that data that fast. That's all how it means to deploy globally. So in conclusion, what I'm saying is Microsoft has given us some great tools at no cost to enter the world of cloud development. CosmosDB Emulator, no cost whatsoever, free to choose. Data migration tool. Yes, ma'am.
On the emulator, as a, you're going to do it locally, is there a way to share visualization or view or access to that data before you publish it out to like your data quality vendor to check it before you publish it up to the cloud?
So the question is before you go to publish to the cloud, is there a way to have people look at the emulator and use that as an example for data quality? Correct? Yes, it would just have to have access to that URL, that connection string. You could build a whole application to work with that and build out the whole processes, and then when you go to the cloud, you just change that connection string, and everything you've built will just work. Right. Again, that's just the connection string. You can share that connection string out to anybody or any application. Right, as long as it can consume that Cosmos DB. We can talk more after if you want. So here's some resources. Right, so welcome to Azure Cosmos DB. Good information there. There's cheat sheets. Okay, dismiss. There's cheat sheets. There's a playground if you want to play around with it. And there's also the SQL queries place to go and try your querying language. PowerBI Desktop, everybody here should go out and get it. It is a great tool for visualizations. You saw how I just in a few clicks made a world map of information. I mean, that is a good, strong thing to use and understand. And please, 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 session evaluations. We live and breathe by these. If I did something good today, tell me. If I did something that sucked, tell me. That's how I get better. We're going to even bribe you. You have until Friday at 5 p.m. on the 15th, and you win prizes. So please fill those out. And thank you very much for your time.